Hello, this lesson will cover growth and decay. So we know that the value of the y-intercept of the value y, the y-intercept is always the value of a in this case, and we know x is always 0. Okay. Now the b part, we know that b, if b is greater than 1, then that implies that we're looking at a growth graph. But if b is in between 0 and 1, meaning it's a fraction or a decimal that is less than 1 but more than 0, then that represents decay. So I'm going to go over these examples quickly. So let's see. So we have -1 for x. That means in the power, in the exponent of 3 is -1. So this, what you have to do is to make the 3 positive, the power positive, just write on 1 over 3, and that was covered in the lesson on the last unit. So when x is -1, y is 1/3. What about when x is 0? Anything to the 0 power is 1, so that means y is 1 when x is 0. 3 to the first power is the same as 3, so when x is 1, y is 3. So what I'm going to do next is I'm going to sketch the asymptote, and this is to remind me that I cannot get past the asymptote when I graph. So if I go left 1, I'm going up 1/3, which is barely noticeable. If I go nowhere for x, meaning no left or right, then I go up 1, so this is the y-intercept. And if I go right 1, up 1, 2, and 3, then I connect the points. And this is the graph for that function. And for example number 2, notice that we have a 4. So in this case, the value of a is 4. So you can expect the y-intercept to be 0, 4 for that one. Okay. So let's do the work for this. So we have 4 times 2 to the negative first power. We know this becomes 1/2. So this is the same as 4 times 1/2, which we know is equal to 2. Okay. And then the next one is 4 times 2 to the 0 power. Well, anything to the 0 power is 1. So this is 4 times 1, which is equal to 4. The last value we have when x is 1. So 4 times 2 to the first power is just 2. So this is equal to 8. So when x is 1, y is 8. Then again, I'm going to sketch the asymptote before I do anything else. So this is the asymptote, and this is will just remind me that I can't get past the asymptote when I graph. So left 1, up 1 and 2. No left to right, so that means you stay here at the origin for x and then go up 1, 2, 3, and 4 for y. And if I go right 1, then I need to go up 8, which is this point here. So then this is what the graph of this function looks like. Okay. And let me just go back and mention real quick that, as you can see, this graph is an example of growth, because when you look at the graph, it's growing, right? So this growth, when it's growth, it looks like this, but when it's decay, then you see something different. You see something like this, okay, when you graph it. So we know this is an example of a growth problem, and this one is also growth. Okay, so let's go to example number 3. So for example number 3, again, we have 1 over 3 to the power of x. So then this is 1 over 3 to the negative first power. And this is the same. Since this is a negative power, that means this is actually the reciprocal of 1/3, which is 3. So when x is -1, y is +3. What about when x is 0? Don't forget, anything to the 0 power is 1. So when x is 0, y is 1. What about when x is 1? Well, this just gives you 1/3. So that means when x is 1, y is 1/3. So let's sketch the asymptote again. Okay, so we have that line, and then if I go left 1, up 1, 2, and 3. If I go no left or right, then I go up 1. So again, this is the y-intercept. And if I go right 1, I go up 1/3. So this will be barely noticeable. And as you can see, this graph is an example of decay. Okay, because this is decreasing as x goes to +infinity. So let's go on to example number 4. Again, I'm going to do the work for this. So this is, we have a -2. Okay, and then this 1/4 is being raised to the negative first power. So in this case, we take the reciprocal. So we actually end up multiplying -2 times 4. And negative 2 times 4 is the same as negative 8. The next one is negative 2 times 1/4 raised to the 0 power. This is the same as negative 2. 1/4 to the 0 power is 1. So then when x is 0, y is negative 2. The next one, when x is 1, so we have negative 2 times 1/4 to the first power. This is the same as 1/4. So you're actually multiplying negative 2 times 1/4, which is negative 1/2. So when x is 1, y is negative 1/2. Next, let's sketch the asymptote. And then we'll plot those points. And we'll see what happens here. Okay, so if I go left 1 from the origin, I'm going down 8. So this is left 1, down 1, 2, 3, 4, 5, 6, 7, and 8. That's that point. And then on the left or right, so down 2. This is the y-intercept. And then if I go right 1, down 1/2. So as you can see, this graph is again an example of growth because the graph is going up as we go from negative infinity to positive infinity. So this is an example of growth. All right, next example. For the next one, we have a negative in front of the 4. So then I'm going to keep that negative. So this will be raised to the negative first power. So then this one here becomes negative 1/4. What about when the power is 0? Again, anything 0, 0 power is 1. So this becomes negative 1. And I forgot to write this here, so this is negative 1/4. Last, when x is 1, so negative times 4 to the first power. Well, this is just going to be negative 4. So next again, let's plot the asymptote. I'm going to sketch the asymptote and then plot the points and connect them to sketch the graph. So left 1 up, down 1/4. So this is down here, about right there. Okay, 0 down 1. And then right 1 down 1, 2, 3, and 4. So as you can see, this graph is an example of decay. A decay problem. So there is the graph, and I'll just write that here, that this is decay. Okay, so for the next part, this is the formula that helps you determine if you're looking at a problem that has represents growth or decay, where x, which is the exponent, represents the time period. So it could be a year, it could be a month, it could be 2 months, it depends. Okay, but this x represents time. A represents the initial amount, if it's money, if it's medication. And B, if it's growth, then what you do is you add, you take 1 and you add the rate, which is an interest, a percent, right? So that the interest is a percentage. If it's decay, then you subtract the rate or the value of R, which again is a percent. So for example, number 6, this is, we have a $300 invested in an account earning 5% interest compounded annually. So annually means, so this will be every year. So that's going to be the x value. So the equation looks like this. So first we have y equals, the initial amount is 300. Okay, then open parentheses. And now let's get the b value. So the b value, since this is earning money, that means it's growth. So all you have to do is add 0.05 to 1, which is equal to 1.05. So then this is 1.05 for b, and this is the equation for that problem. Okay, that's the function that will give you any time you want to compute here or you want to calculate. Number 7, caffeine is eliminated. So this is B, you subtract the rate from 1. So caffeine is eliminated from the bloodstream at a rate of 12%. So the rate is 0.12. So then per cup, a cup of coffee has 150 milligrams of caffeine. So this is the value of A. So then the equation is y equals 150. And now let's get the B value. So the B value is 1 minus the rate, which in this case is going to be equal to 0.88. Because 1 minus 0.12 is 0.88. So then that goes here, 0.88. And this gets raised to the power of x, which represents the amount of time. Okay. Example number 8, a Les Paul guitar was bought for $1,200. So this is the initial amount. Experts estimate that its value will increase. So that means it's going to grow by 14% per year, which means the rate is 0.14. So then to find b, just add 1 plus 0.14, so b is equal to 1.14. So then to write the equation, we have y equals the initial amount, which is $12,000, and then let's see, so then b is 1.14 raised to the x. Okay, so this is the equation that will help you answer any questions about this problem. The last example, a car is purchased for $18,700, so that's the initial amount, and it depreciates, so that means you subtract the rate from 1 at a rate of 9% per year. So then the rate is 0.09 when you convert it to decimal. So b is equal to 1 minus 0.9, which is equal to 0.91. Okay, so then the equation for this problem is y equals the initial amount, again, is 18,700, and the b value is 0.91 raised to the power of x. So there you have examples of how to determine growth and decay. And again, just pay close attention to the words that are being used on the problem. Okay.